So this is a good time for a quick recap of the last couple of lessons. Here we have two models, the bad model on the left and the good model on the right. And for each one of those, we calculate the cross entropy, which is the sum of the negatives of the logarithms of the probabilities of the points being their colors. And we conclude that the one on the right is better because the cross entropy is much smaller. So let's actually calculate the formula for the error function. Let's split into two cases. The first case being when y equals 1, so when the point is blue to begin with. The model tells us that the probability of being blue is the prediction y hat. So for these 2 points, the probabilities are 0.6 and 0.2. As we can see, the point in the blue area has more probability of being blue than the point in the red area. And our error is simply the negative logarithm of this probability. So it's precisely minus logarithm of y hat. In the figure, it's minus logarithm of 0.6 and minus logarithm of 0.2. Now, if y equals 0, so when the point is red, then we need to calculate the probability of the point being red. The probability of the point being red is 1 minus the probability of the point being blue, which is precisely 1 minus the prediction y hat. So the error is precisely the negative logarithm of this probability, which is negative logarithm of 1 minus y hat. In this case, we get negative logarithm of 0.1 and negative logarithm of 0.7. So we conclude that the error is negative logarithm of y hat if the point is blue, and negative logarithm of 1 minus y hat if the point is red. We can summarize these two formulas into this one. Error equals negative 1 minus y logarithm of 1 minus y hat minus y logarithm of y hat. Why does this formula work? Well, because if the point is blue, then y equals 1, which means 1 minus y equals 0, which makes the first term 0, and the second term is simply logarithm of y hat. Similarly, if the point is red, then y equals 0, so the second term of the formula is 0, and the first one is logarithm of 1 minus y hat. Now the formula for the error function is simply the sum over all the error functions of the points, which is precisely the summation here. That's going to be this 4.8 we have over here. Now by convention, we'll actually consider the average, not the sum, which is where we're dividing by n over here. This will turn the 4.8 into a 1.2. From now on, we'll use this formula as our error function. And now, since y hat is given by the sigmoid of the linear function wx plus b, then the total formula for the error is actually in terms of w and b, which are the weights of the model, and it's simply the summation we see here. In this case, yi is just the label of the point x superscript I. So now that we've calculated it, our goal is to minimize it, and that's what we'll do next. And just a small aside, what we did is for binary classification problems. If we have a multi-class classification problem, then the error is now given by the multi-class entropy. This formula is given here, where for every data point we take the product of the label times the logarithm of the prediction, and then we average all these values. And again, it's a nice exercise to convince yourself that the two are the same when there are just two classes.